Have you ever wondered how a single port container crane can lift a steel shipping container weighing tens of thousands of kilograms and place it with astonishing precision, all in less than a minute? Every day, these towering giants quietly move the cargo that keeps our modern world alive. From smartphones and cars to food, clothing, and medical equipment, almost everything we use has likely passed beneath one of these incredible machines. But behind their enormous size lies an engineering masterpiece that few people ever get to see. At first glance, a port container crane looks simple. A massive steel frame stands beside the water while a trolley glides across a long horizontal beam, lifting containers from ships to trucks or trains. Yet every movement is the result of carefully coordinated engineering, powerful motors, advanced control systems, and the skill of highly trained operators. The question is, how are these giants designed and built to handle such extraordinary loads day after day, often in some of the harshest coastal environments on Earth? The answer begins long before a crane ever arrives at a busy harbor. It starts with years of engineering, thousands of precision-manufactured components, and one of the most demanding industrial manufacturing processes in the world. And as we continue, you'll discover why building one of these machines is far more complex than simply assembling pieces of steel. The story of port container cranes dates back to the revolution of containerized shipping in the mid-20th century. Before standardized shipping containers became common, cargo had to be loaded and unloaded by hand or with small lifting equipment. This process was slow, expensive, and vulnerable to damage. Everything changed when standardized steel containers transformed global trade, allowing goods to move seamlessly between ships, trucks, and railways. As cargo ships became larger and international trade expanded, ports needed equipment capable of lifting heavier loads while reaching farther across increasingly massive vessels. Engineers responded by designing specialized ship-to-shore cranes, often called STS cranes. These enormous machines dramatically reduced loading times and helped reshape the global supply chain. Today, many of the world's busiest ports depend on these cranes operating around the clock to keep international commerce moving. Building one of these engineering giants begins with carefully selected raw materials. Steel forms the backbone of almost every component because it combines exceptional strength with the ability to withstand constant stress. Different grades of structural steel are chosen depending on where they will be used. Some sections must resist bending under tremendous weight, while others must endure years of repeated movement without developing fatigue, a gradual weakening caused by millions of loading cycles. Equally important are the high-strength steel cables that perform the actual lifting. These wire ropes consist of hundreds or even thousands of individual steel wires twisted together to create remarkable flexibility without sacrificing strength. They must support enormous loads while winding smoothly over pulleys thousands of times throughout their service life. Powering every movement are massive electric motors, precision gearboxes, industrial bearings, and sophisticated electronic control systems. Copper plays a vital role in electrical wiring because of its excellent conductivity, while advanced coatings protect steel surfaces from corrosion caused by salty sea air. Every bolt, bearing, hydraulic component, and electrical connector must be chosen with durability in mind because these cranes are expected to operate reliably for decades with proper maintenance. But, selecting the right materials is only the beginning. Turning thousands of individual parts into one of the largest moving machines ever built requires extraordinary engineering precision. In the next part, we'll step inside the design offices and manufacturing halls where these towering Today, many of the world's busiest ports depend on these cranes operating around the clock to keep international commerce moving. Building one of these engineering giants begins with carefully selected raw materials. Steel forms the backbone of almost every component because it combines exceptional strength with the ability to withstand constant stress. Different grades of structural steel are selected depending on where they will be used throughout the crane. Some sections must resist bending under tremendous weight, while others must endure millions of loading cycles without fatigue. Equally important are the high-strength steel cables that perform the actual lifting. These wire ropes consist of hundreds or even thousands of individual steel wires twisted together for maximum flexibility and strength. They must support enormous loads while winding smoothly over pulleys thousands of times throughout their service life. Powering every movement are massive electric motors, precision gearboxes, industrial bearings, and sophisticated electronic control systems. Copper plays a vital role in electrical wiring, while advanced coatings protect steel surfaces from harsh salty sea air. Every bolt, bearing, hydraulic component, and electrical connector is selected for maximum durability. But selecting the right materials is only the beginning. Turning thousands of individual parts into one of the largest moving machines ever built requires extraordinary engineering precision. Before a single piece of steel is cut, engineers spend months designing every detail using advanced computer modeling. These digital models simulate real operations. Moving a completed port container crane to its destination is a remarkable engineering project on its own. Because these cranes are simply too large to travel by road, manufacturers generally transport them by sea. Some are shipped as massive pre-assembled structures on heavy-lift vessels, while others are built in sections and reassembled at the port. Every stage is carefully planned because even a slight miscalculation could affect a structure weighing thousands of tons. Once the crane arrives, engineers spend weeks completing the final installation. Every electrical connection is checked, moving components are calibrated, and software systems are tested repeatedly before commercial operations begin. Only after passing a final series of inspections does the crane officially become part of the port's daily operations, ready to load and unload thousands of containers with remarkable speed and precision. One surprising fact is that many people assume the crane lifts containers using brute force alone. In reality, precision is just as important as power. A container often has to be placed within a very small margin of error onto a truck chassis or between stacks of other containers. Even a tiny mistake can slow an entire terminal, which is why advanced positioning systems and experienced operators are so valuable. Another little-known fact is that the tallest ship-to-shore cranes can stand higher than many city skyscrapers when their booms are raised. Their enormous height allows them to reach across the widest container ships ever built, vessels capable of carrying many thousands of containers on a single voyage. As global shipping continues to evolve, crane designs must grow alongside these increasingly massive ships. Perhaps the most impressive fact is that these cranes rarely stop working. In many major ports, operations continue day and night throughout the year. Careful scheduling and preventive maintenance allow cranes to remain reliable despite performing countless lifting cycles over decades of service. Their consistency is one of the hidden reasons why products from around the world arrive in stores with such efficiency. Like every major industry, crane manufacturing and port operations also face environmental challenges. Producing large quantities of structural steel requires significant energy, and ports have traditionally relied on equipment powered by fossil fuels. However, the industry is steadily changing. Many modern ship-to-shore cranes operate entirely on electricity, helping reduce direct emissions during daily operations. Manufacturers are also improving production methods to reduce material waste, recycle scrap steel, and apply longer-lasting protective coatings that extend the crane's working life. Ports themselves are embracing smarter energy management, regenerative braking systems, technology that captures energy while lowering heavy loads, allow some cranes to return electricity to the power system instead of wasting it as heat. Digital monitoring also helps optimize operations by reducing unnecessary movements and improving overall efficiency. While challenges remain, research across the industry suggests that future ports will become cleaner, quieter, and increasingly energy efficient. The next generation of port container cranes is already taking shape. Artificial intelligence is helping optimize lifting sequences, predict maintenance needs, and improve traffic flow throughout busy terminals. Digital twins, virtual replicas of real machines, allow engineers to monitor crane performance continuously and identify potential issues long before failures occur. Some manufacturers are also developing even greater levels of automation, where cranes, trucks, and container yards communicate seamlessly to move cargo with minimal delays. As international trade continues to grow, these towering machines will remain at the heart of the global supply chain. They are far more than giant steel structures. They represent decades of engineering innovation, precision manufacturing, skilled craftsmanship, and technological progress working together to connect continents. Every container they lift carries more than goods, it carries the countless ideas, resources, and human effort that keep the modern world moving. So the next time you see a container ship arriving at a busy harbor, take a moment to look beyond the stacks of colorful containers. Standing beside them are some of the most extraordinary machines ever built, quietly performing one of the most important jobs in global commerce. And if you enjoyed discovering how these engineering giants are designed and manufactured, don't forget to like the video, subscribe for more industrial documentaries, and share in the comments which incredible machine you'd like to explore next. The moment a completed port container crane is switched on, thousands of individual components begin working together in perfect harmony. Powerful electric motors quietly drive the trolley across the boom while separate motors control the hoist, raising and lowering containers with astonishing precision. Unlike older lifting equipment that relied heavily on manual control, many modern cranes use automation systems that constantly calculate the safest and most efficient path for every movement. One of the most impressive technologies is the anti-sway system. Whenever a heavy container is suspended from long steel cables, it naturally wants to swing like a pendulum. Left uncontrolled, this movement could slow operations and increase risk. Advanced sensors and computer software automatically detect even the smallest swing and adjust the crane's movements to keep the container remarkably stable. What looks effortless from the ground is actually the result of thousands of calculations happening every second. Many of today's busiest ports are also introducing semi-automated and fully automated container terminals. Cameras, laser scanners, GPS positioning, and artificial intelligence work together to guide cranes with incredible accuracy. Some cranes can automatically identify containers, calculate their exact position, and transport them with minimal human intervention. Even so, trained operators continue to supervise these systems, ready to take control whenever unusual conditions arise. Technology has made cranes smarter, but human judgment remains one of the most valuable safety systems. Behind every successful port operation is a team of highly skilled professionals. Crane operators spend months, and often years, developing the experience needed to control machines that may weigh well over 1,000 tons. Sitting high above the dock with a panoramic view, they carefully coordinate every lift, often placing containers within just a few centimeters of their target. Their work demands concentration, precision, and excellent communication with the ground crew below. Supporting the operators are maintenance engineers, electricians, welders, mechanical technicians, and automation specialists. They inspect motors, replace worn components, lubricate moving parts, and update software that controls the crane's electronic systems. Preventive maintenance, servicing equipment before problems occur, is essential because even a short interruption can affect the movement of thousands of containers and delay ships worth millions of dollars. Quality control begins long before the crane reaches a port. Every major steel component is carefully inspected for dimensional accuracy. Many critical welds undergo non-destructive testing, a method of examining materials without causing damage. Techniques such as ultrasonic testing use high-frequency sound waves to detect hidden cracks inside thick steel, while magnetic particle inspection can reveal tiny surface defects that are invisible to the naked eye. After assembly, the crane enters one of its most demanding stages, load testing. Engineers lift specially designed test weights that simulate real shipping containers, sometimes approaching the crane's maximum rated capacity. Every movement is monitored closely to confirm that the structure, motors, brakes, cables, and control systems perform exactly as intended. Sensors record how the crane responds under heavy loads, allowing engineers to verify that it meets strict international safety standards before entering service. Safety is built into every level of the crane's design. Multiple braking systems ensure that suspended containers remain secure even if one component fails. Wind monitoring equipment continuously measures weather conditions because strong coastal winds can affect crane stability. If wind speeds exceed safe operating limits, lifting operations are temporarily suspended to protect both workers and equipment. Operators also rely on collision avoidance technology that helps prevent cranes from striking nearby structures or other machines. Emergency stop systems are positioned throughout the crane, allowing immediate shutdown if necessary. Access platforms include guardrails, anti-slip surfaces, and fall protection systems so maintenance crews can work safely at significant heights. Every inspection, maintenance procedure, and operating rule exists for one reason: protecting people while keeping one of the world's busiest industries running smoothly. At this point, the crane has proven its strength, accuracy, and reliability. But its journey isn't over yet. Before it can begin moving millions of containers across the globe, it must be prepared for one final challenge: transporting one of the largest machines ever manufactured to the port where it will spend decades serving global trade.